We have seen that vascular structures are best appreciated on the T2 weighted images. Let's have a look at the reason for these appearances. Let's say you are trying to acquire this particular slice where there are multiple protons are present. Some are the stationary protons like in the brain parenchyma, and some of them are moving protons which are present in the blood vessel, let's say the superior sagittal sinus. When you apply the 90-degree pulse, all the protons in this particular slice take up that energy and they get excited. But before you apply the 180-degree pulse, the protons in the blood vessel, as they are moving, they'll move to a different location. So the initial proton which got affected by the 90, it has moved out of the slice. When you get the signal, the protons which got affected by both the 90 and 180-degree pulses, they only give some signal, whereas the protons in the blood vessels, they are not affected by both the pulses. Some protons got affected by only 90 and some protons got affected by only 180. So they will not give any signal. That is why moving protons will not give any signal on the spin echo sequences. That's why they are called as flow voids or signal void. Now let's have a look at why T2 is more important. Previously we have seen the two parameters, that is the TR period and the TE period. Just to elaborate on these parameters, TE is time of echo, or the time period between the application of 90-degree pulse and the acquisition of echo. And the 180-degree pulse is always applied exactly at half the time of TE. That is important to remember, because in T1 weighted images, the TE times are very short. When the TE time is short, the time gap between the 90 and 180-degree pulse is also short, and the protons will not be able to move out of the slice in this short period of time. If you are looking in the T2 weighted images, the TE period is very long in T2 weighted images. Because the TE period is long, the time gap between the 90 and 180 is also long, so that the moving protons will be able to move out of the slice easily, thereby maintaining the normal flow void appearance. For this reason, T2 weighted imaging is always the best sequence to look at the flow voids.